We already learned about what equilibrium is. We learned how to calculate the equilibrium constant to see if the products are favored or whether the reactants are favored. Now here we're gonna learn about one more value, and this K value, we're calling it the solubility product. The solubility product, so that is what SP stands for. It is solubility product. And I'll explain what that means later. Okay, so here it says the solubility product constant, KSP. This particular constant is only used for saturated solutions. It's something that can dissolve. And it can't just dissolve completely. This value only works if a solution is slightly soluble. The larger the K value is, the more soluble it will become. And I'll show you what that means in a bit. It says here, complete the following dissociation and write the solubility product constant expressions. That you have a substance that's a solid. So I'm going to write it down. Calcium carbonate. It's a solid. And it's soluble. Okay, it's soluble, so it's going to dissolve. So if you guys recall, calcium has a +2 charge and carbonate has a -3 charge. So when this dissolves, you split them up into ions. So calcium aqueous plus carbonate aqueous. Okay, so what this is saying is that only a little bit of this is going to dissolve to form these ions. So that means that KSP is going to be a small number because it's mostly going to remain in its solid form. So you'll usually see a negative power for KSP. So again, this is slightly soluble, but we want to figure out how much of these products are we going to have at equilibrium. So how would you write the expression? So it says here, complete the following dissociation and write the solubility product constant expression. So what that means is you're going to write KSP. So I know we normally write EQ down here. SP just means that it's more specific. It's related to solids that are soluble. And so anytime you deal with solubility products or something that's soluble, you usually don't have anything in the denominator. And look, because it's products over reactants, right? Products include aqueous solutions, so we include them in the constant, but we learned that we don't include solids or liquids. So we're not going to have anything in the denominator. So we're going to have the concentration of calcium times the concentration of carbonate. And that would be our KSP expression. That's it. So if you want to find what KSP is, you just plug in the concentrations of these ions and then you'll get your K value. And the K value again will tell us how soluble this equilibrium reaction really is. Okay, so if you feel comfortable, you can do number 2 and 3. It says to complete the dissociations. So I'm going to do it right here. Hopefully you tried. I would try. So Mg3, PO4, -3, and this is +2, right? Magnesium we know is +2, and then if we crisscross backwards, this would be -3. Or you just look at your flashcards and PO4 has a -3 charge. Again, it's a solid. Always assume it's a solid because it's going to dissolve. So anytime something is asking for a solubility product, know that the solid is on the left side. And then when you dissolve it, you have 3 magnesiums. Okay, so you're going to put 3 in the front. You have 3 magnesiums. And you have 2 phosphates, right? Here there's 2. You don't put the 2 down here on this side because it's not joined together anymore. It's now separated. It's forming ions. So they're not together anymore. So that's why we put a 2 in the front and a 3 in the front. And so now we're gonna solve for KSP. So it's gonna be mg plus 2 to the third power times PO4 concentration to the second power. And then again, we don't include solids, so we'll have nothing in the denominator. So we have aluminum hydroxide. Aluminum is in the third column, so it's plus 3. OH has a -1 charge. You guys might want to review your flashcards, your polyatomic flashcards. And then you have a 3 here. It's solid, and then it's gonna dissolve. We have 1 aluminum, and we have 3 hydroxides. And then when you solve for KSP, you're gonna get a concentration of aluminum times concentration of hydroxide to the third power. Okay, so that is how we find the expressions for something that is dissolving. So the first question says calculate the KSP. So we're dealing with a solid that is gonna slightly dissolve, right? And this solid is gonna be FeS, which is iron sulfide, and it has a solubility of 6.1 times 10 to the -10 moles per liter. So whatever, that's how much, that's the concentration that is going to result in ions, in ion formation. So even if you don't know what to do, the first thing you should do is write your equation. So iron sulfide. And we know sulfur is -2 charge because it's in the 6th column. And if this is -2, then this has to be +2 because it's a 1-to-1 ratio here, right? We know it's a solid because we're dealing with a solubility product, and this is going to slightly dissolve. So I'm going to separate it into ions like that. And it says that this has a solubility of 6.1 times 10 to the -10 power. So 6.1 times 10 to the -10 molarity, that means that much is going to dissolve. And because we have a 1-to-1-to-1 ratio, that means for every one of these, you're going to produce one of these, and you're going to produce one of these. So that means that if you have 6.1 times 10 to the -10, then you're also going to have this much iron cation and this much sulfide anion. Okay, so now we could calculate KSP. We know KSP is the products times the other product, right? They're both aqueous. And then solid, you don't include it. So because we know these guys, we could just plug them in. Just literally just plug them in. And because it's the same, right? Because it's the same concentration, we could just put 6.1 times 10 to the -10 squared because we're multiplying by the same number. Or you could also just put 6.1 times 10 to the -10 times 6.1 times 10 to the -10. You'll get the same answer. So I'm going to do it this way. And I end up getting 3.72 times 10 to the -19. Again, -19 implies a very, very small number. And if it's a very, very small number, that means the reaction is going to lean towards the left. And it makes sense because only a little bit of solid is going to dissolve. So this number makes sense. Remember, K does not have units. We'll do that one together one more time. Oh, where's my notebook? Right, it says calculate the KSP, the solubility product constant, for manganese hydroxide that has a solubility of 2.2 times 10 to the negative 5 moles per liter. So again, we're going to start off with our equation, Mn manganese hydroxide, right? We know this is -1 according to our flashcards, and therefore if you crisscross backwards, you get +2 there. It's a solid, and we're going to separate it. Mn plus 2 aqueous plus 2 hydroxides. Okay, so this is tricky because we don't have a 1:1:1 ratio anymore. We have a 1:1:2 ratio. And it says that this substance right here has that solubility. So it has a solubility of this much. So that much is going to dissolve. And because this is a 1:1 ratio, we're going to have the same amount of manganese, but here it's going to be double, so you're going to multiply by 2, so you're going to double this, so it's going to be 4.4 times 10 to the negative 5. Okay, so now what you're going to do is set up your expression, which is products over reactants, but remember solid is not included because that's the rule. It's already constant in the reaction, right? And then OH negative to the 2 power. So when you substitute Mn, you're going to get 2.2 times 10 to the negative 5. And then when you substitute hydroxide, you're going to put 4.4 times 10 to the negative 5 to the 2nd power. Now, when you do the math in your calculator, you're going to get 4.26 times 10 to the negative 14. All right, now that you have 2 examples, I want you to try example 3. You need to try, otherwise you're not going to get it. So hopefully you wrote your equation. Ag2, which is silver carbonate, right? This has a plus, let me write this again. So Ag2CO3. CO3 has a -2 charge, right? And because there's a 1 right here, then silver is going to be +1. Okay, and it's a solid because it's going to dissolve. You have 2 silvers that are dissolving, and you have 1 carbonate that is dissolving. Okay, when you read the question, it says that our solid is soluble at 1.3 times 10 to the negative 4. That is the concentration that is going to dissolve. But for every one of these, you're going to produce 2 silvers. So this is going to be 2.6 times 10 to the negative 4. And here it's going to be a 1 ratio. So it's going to be the same as this guy. It's a 1:1 ratio. So it's going to be 1.3 times 10 to the negative 4. Okay. Now, KSP is equal to products, silver, to the 2nd power times carbonate, ion, to the 1st power. And when you substitute in your values, this is 4. You're going to get a number for KSP, and hopefully you guys got this number. All right, there's that. Here you have silver iodide. Silver iodide, it's a solid. It's going to dissolve. Right, 8 halogens, -1. And because it's a 1-to-1 ratio here, it's going to be +1. And it says that the KSP is given to us. So let's say that we don't really know what to do. The first thing we could do, the only thing we could do is just set up our expression. So that's what we're going to do. KSP is equal to the concentration of silver times the concentration of iodide, right? It's a 1-to-1 ratio. You don't include the solid. And what it's saying is that we have the KSP value. What is the concentration of, we're actually going to get rid of this. What is the concentration of this and this and so okay, so let's start over. Okay, so hopefully you try this one, and some of you guys probably got stuck, and that's fine. So we have AgI, which is silver iodide, right? It's a 1-to-1 ratio. So because iodide is -1, according to our periodic table, then this guy has to be +1. It's a solid, it's gonna dissolve. So we have silver and iodide. That's how we separate it into ions. Here, this question is a little different because it's not asking for KSP now, it's giving us KSP. We could write our expression and go from there. So we're gonna write our expression. KSP is the concentration of silver times the concentration of iodide. And we know what KSP is. It's 1.5 times 10 to the -16. We don't know what silver is. We don't know what iodide is. So what we could do is treat these as x. So 1x, and then this is also 1x. So what is x times x? It's x squared. And how do you get rid of the squared? You take the square root. And when you take the square root of that, you're going to get a number. Okay, so I'm going to get 9.22 times 10 to the -9. And what x is, it's going to represent the concentration of these guys. So that means that if this is 9.22 times 10 to the -9, and this is 9.22 times 10 to the -9, then that means this has to be 9.2 times 10 to the -9, since it's all a 1-to-1 ratio. Okay, so hopefully you guys tried. I'm going to write my equation, Mg, magnesium hydroxide, and it's a solid. It's going to dissolve. And you have 2 hydroxides, right? And it says that KSP is given to us. So what is the solubility of this salt right here? So what we're going to do is we're going to have to figure out what these concentrations are in order to figure out this one right here. So we're going to write our expression. Right, and let's do the second power here. We know what KSP is. It's 1.2 times 10 to the -11, right? We don't know what Mg is, and there's only a 1 here. So I'm going to put X. And then we don't know what OH is, so we're going to leave that. as 2x to the second power. So remember, the concentration has doubled what x is, so you have to put a 2 here. That's what makes this question difficult. You have to put a 2x there. And then you solve for x, and you guys know that this is, I'm just going to rewrite it. Hopefully your algebra is strong. This is the same as x times 4x squared, right? And then when you do this, it's 4x cubed. And when you solve for x, you take divide by 4 here, right? You divide by 4 here. And x to the third is the same thing as taking that to the power of 1/3. So hopefully you know how to do this algebra. X is going to end up being 1.44 times 10 to the negative 4 power. So that is going to be x. So if that is x, if magnesium is x, then that means that also has to be x, right? It's a 1-to-1 ratio. This is x, this is x, this is 2x. The question is saying calculate the solubility of the salt. So if we solve for x, which is this, then that's the concentration of Mg. And if that's the concentration of Mg, then that's how much salt was dissolved. So that would be our answer. Okay, so go ahead and try the last one. Hopefully you guys can nail that one. Okay, so here it is. Pb, which is lead. Chloride, this is -1. Then the 2 is crisscrossed backwards like that. This would be a solid. You dissolve it. And you have a 2 here. So it separates. So remember, it's not CO2 anymore. It's not a gas. It's something that dissolves. So you have to put the 2 in the front because it shows that 2 moles of chlorine will dissolve. And now we can write our expression. And chlorine is going to be to the second power because that's the rule. We know what KSP is. It's 1.6 times 10 to the negative 5. And we don't know what these guys are, so we're going to set them as x. Okay, x to the 2 power. Right, we just literally just replace these with x. And when we solve for x, we could figure out what this is, and whatever this is, because it's a 1-to-1 ratio, that will represent that as well. Be x to the 3rd power is equal to 1.6 times 10 to the negative 5. And you cube root this, right? You guys cube root this. And one way you could do it is by taking this to the 1/3 power. So that will give you x. Or you could just use your calculator buttons and see if you can find the cube root. X is going to equal 1.59 times 10 to the 2nd power. What was it? Negative. I think it's -2 power. That is what x is. Therefore, that is the concentration of the ion that forms. And if that's a 1-to-1 ratio, then that's the same concentration for our soluble PbCl2. So by soluble, it means that that's the amount of solid that can actually dissolve. Okay, it's not the concentration of all of it. It's only the amount that's gonna dissolve. Okay, so there's a difference. Hopefully that made sense. Go ahead and do the problem set and ask questions if you have them.